So last week we looked at R format, and we said that there are three basically bit patterns for the instructions. So just to do a quick recap, we said when you have instruction, for example, you have this add I, and then you have S0, S1, and 5. So when you have this instruction and you type this one in your Mars, when you compile that and you're trying to basically run that, the processor doesn't understand this directly. So when you compile this one or assemble this one, this instruction is going to be basically a number. So there is a specific pattern, and these are the patterns that we're talking about here, that let's say this instruction is going to be, for example, 0, 0, 0, 0, and I'm just putting like random numbers. So, and then continues. So this is gonna be 32 bits. So then the processor can read this. So when you assemble, after you get this instruction converted to this 0 and 1s, 32 bits, 0 and 1s to be exact, this is going to be stored in the memory. So somewhere in the memory, you have some address, and then you have the content. So this is going to be your instruction 1, instruction 2, instruction 3, and so on. So each line of your code is going to be basically written on the memory. And then the processor is going to start looking at the beginning. That is a prefixed address. That's like the start address. And it's going to start reading each instruction from here and basically running this instruction, and then going to the next one and running this instruction. And so that is the process of assembly, that basically this instruction that is human readable. So you see, like you have, like add, subtract, and things that we understand easily, is actually converted to 32 bits. And that's how the MIPS is designed. So the processor, that all the instructions, so it's very, basically it's engineered in this way, that all these instructions are 32-bit each. So you have many instructions, and there is, of course, limited size in this 32 bits, because you have some bits for what is the instruction itself, and then you have some bits for these registers to specify what are each register, or maybe you have a number in this case. So there are many, there's restriction, but the way that is engineered, that you can, basically they made this to work with 32 bits only. So that is kind of like a quick recap of what I've been doing. So last week we talked about the R format. So this was the whole topic of the last week, and we said that there is some instructions. So for example, the add is one type, and usually not always, but usually the R format, you have 2 registers. So that was how quickly we could guess that this instruction is R format. And if it's the R format, this is going to be the 32-bit pattern, and how it's going to be divided. So yeah, these are some examples, and we talked about this. So here is the label of the R format instructions. Here is the list of the R format instructions, and we can basically look at these to know what is the pattern of each one. And most of these, they have 2 registers. Some of them, they have only 1 or 2 registers. But when the other registers are not set, basically you get some bunch of zeros in your pattern. So that's basically a quick recap. This week, we are going to look at the I format. So that would be the second one here.